First, a little bit more about our presenters today. My name is Riley Francis. I'm the solar coach at StraightUp Solar. I've been on the StraightUp Solar team since 2018, and I enjoy the work that I do because it's work that I can do that is helping people and helping the planet. And today I'm joined by Jim Dixon, a solar project developer at StraightUp Solar. Jim's background is in the financial industry. He was a stockbroker, bond trader, and institutional equity broker. And he's used that financial knowledge to help aid his work as a solar project developer. And today we're joined by Asher Levinson, the account manager at Enphase Energy. He's been with Enphase since 2019 and has been in solar since 2018. His background is in environmental engineering and he loves all clean tech. And a little bit more about StraightUp Solar. We were founded in 2006 and we serve Illinois and Missouri. We have over 1,700 installations to date. We're a part of the Amicus Solar Cooperative and we're a certified B Corporation. We have over 85 employees and almost half of our employees have their NABCEP certification. NABCEP stands for the North American Board of Certified Energy Practitioners, and it's a very trusted certification to know that you're working with solar experts. We're an REC solar panels premium installer, and we have a 10-year workmanship and production warranty. And the topics that we're going to be going over today, first we're going to talk about how does an inverter work. We're going to talk about why your solar system needs an inverter. And then we're going to take a deeper look into Enphase inverters and the benefits they offer. And lastly, we'll wrap up with how you can get started and we'll go through our Q&A session. So at this point, I'll go ahead and turn it over to our first presenter, Jim Dixon, project developer at StraightUp Solar, and he's going to be showing us how does an inverter work.
Okay, excellent. So I have been in the industry for 8 years. I'm not an electrician or an engineer, but I'm very experienced project developer. And so I'm going to talk to you in layman's terms as far as what an inverter is all about, what it does, the different types of configurations. And then Asher will follow me and he can definitely be more technical if needed. But I tell people when you're buying solar, you're basically buying three things. You're buying panels, inverters, and a company that installs you. Tonight, we're going to focus obviously on inverters. The reason you need an inverter with your system is because panels will produce DC current, direct current. Well, in order for your house to be able to use that power, it needs to be converted or inverted to AC power. And that's exactly what an inverter does. Now, when you look at the inverter market, there's two basic configurations, a string inverter system and a microinverter system. We are going to be talking about microinverters for the most part tonight, but I want to tell you that, again, being in the industry for quite some time, I transitioned to the microinverters and specifically Enphase 3-4 years ago. And that's all I show my prospective customers because it's a much more inferior product and configuration. So first I'm going to start by telling you a little about the string inverter configuration, the pitfalls or drawbacks to that system. When you have a string inverter system, one of the biggest drawbacks is you have a single point of failure. You'll have an inverter on the side of the house or your garage, maybe in your basement, and that all the panels will be strung to that single point of failure. Well, the problem is they fail frequently because they thermal cycle, they burn hot. It's almost as though if you put your hand on one of the string inverters, you will feel the heat. Excuse me, it's almost like rolling your car down the highway 100 miles, getting out, putting your hand on the hood of the car. You're not going to burn your hand, but you're going to feel that heat. Well, heat is the culprit. It breaks everything down, and there's no exception with these string inverters. They fail. I don't care what the manufacturer is. They have limited warranties of 10 and 12 years. You can buy extended warranties, but it does not change the configuration. My service department would be the first to tell you that these inverters fail before the warranty period often. And so you have an inverter that burns up at year 6 or 7. You think that you're covered because you have a 10 or 12-year warranty. And then you get the rude awakening, oh, my warranty is severely prorated. You only get a mere fraction of the value. To hire a solar company like StraightUp Solar to come out, buy an inverter, install it for you. You're not going to get an Ameren rebate. You're not going to get a federal tax credit on that. And it's very likely you're going to have to go through this 2-3 times in the life cycle of your system. It gets worse because when you have a string inverter system, all your panels are daisy chained or strung in a series. And the famous analogy that they use, it's like old Christmas lights. If one of those lights go out, you're going to have the rest of the string go down. And you'll have people talk about optimizers that can mitigate that issue to a degree, but you cannot escape the single point of failure issue that resides with a string inverter system. So it's inferior. Once upon a time, they were considerably less expensive than a microinverter solution. Well, like all technology, inverters have gotten more efficient, smaller, better, less expensive. The small premium that you pay for an Enphase microinverter configuration today far outweighs all the drawbacks that you would experience with a string inverter system. So now let's talk about microinverters in general. Micro meaning small. In this configuration, you don't have one central string inverter, one single point of failure. What you have is a very small inverter, a little bit bigger than your cell phone, underneath each and every panel. So now what happens is each panel acts as though it's its own power plant. Each panel takes that direct current that the panel is producing, converts it, inverts it to AC. Now the home, the grid can use the power. All kinds of advantages. You no longer have that one single point of failure. In addition, you have a 25-year non-prorated warranty because these inverters do not run hot like string inverters do. You have much better monitoring because your monitoring is at the panel level on your phone, your laptop, your PC, whatever you choose to go to the internet and take a look at your array. You can see real time what's going on, how much it's producing. You can also look at what did it do in the last week, what did it do in the last month, since inception or for the year. There is no troubleshooting to speak of because you can identify if there is a problem. But back to the warranty and why it's 25 years and it's not prorated. These inverters are incredibly reliable. The failure rate is unbelievably low. So it also mitigates the lost production from shade or other aspects. If a panel is underperforming in a string, it's going to drag down the production of the rest of the string. Not going to happen in an Enphase microinverter solution or configuration because each panel is acting independent of the others. If one panel has a problem, you're going to easily see it on your monitoring, and it's going to be restrained, constricted only to that one panel. So with that, I think that we're going to go ahead and turn it on over to Ashy, and he can dig a little bit deeper or address a couple other aspects of Enphase and all the wonderful things that they're doing.
Right. Thanks, Jim. And thank you, Riley, and the rest of the StraightUp Solar team for having me on. As Riley mentioned earlier, I've been with Enphase now since 2019. My experience in solar, just so everyone knows, prior to Enphase, I was actually working with residential solar up in the Chicagoland area where I live, which was really where I got first introduced to using Enphase. And I fell in love with the technology and the company and had the good fortune of joining just about 2 years ago. Just a little background on who Enphase is. So we were founded in 2006. We're headquartered out in Silicon Valley in Fremont, so just near San Francisco. And the founders of the company were really solving a problem that Jim kind of referenced earlier, which was in the industry at the time, pretty much everybody was using a standard string inverter, which just meant that system production wasn't where it could be. There were a lot of homeowners who didn't have the ability to go solar due to partial shading issues on some of their roof faces, or just complicated roof designs, or anything that might become an issue if you do have a string inverter setup. And the founders were working on a way to solve all those problems. And that's really where they settled on creating the microinverter, where, as Jim mentioned, you're reducing the technology to a size that's so small that it can fit underneath each and every panel. And what you're doing there, as Jim mentioned, is we call it in the industry a distributed architecture. But like Jim said, it really boils down to a system with no single point of failure, where every panel is operating 100% independently of everything else. Since then, we've grown quite tremendously. We are now, we've been a publicly traded company now since 2012. It's a very fun story to watch if you like following stocks. We have shipped and produced millions and millions of these microinverters. You can find them all over the world. I'm also the account manager for Canada, and we have these really, really far north in some pretty cool remote places. So it's really cool to see how much Enphase has shipped and produced. And we're on our 8th generation of microinverters. So we've taken a lot of the learnings from all of the data we've collected since, really implementing microinverters in the field in the 2000s. And we use that to continually improve our product so that by the time it's on your roof, it's got the reliability that Jim mentioned. So if we go to the next slide, you'll see we do have a variety of different microinverters. So just as Jim mentioned, they're very small. They're not much bigger than your phone. If you have a standard size cell phone, if you have an oversized cell phone, it's probably about the same size. And we have 4 different types of these microinverters. We call them SKUs or SKU. And they're listed right there on the right. The different SKUs are really there, and they're designed to provide different types of power outputs, which pair very well with different type modules that you might be getting installed on your roof. There are a variety of modules on the market, and our team has designed just enough variety so that you're covered no matter which panel you're choosing for your roof. And the folks at StraightUp Solar do a great job at making sure everything is paired, just the right way according to what you would want and need for your home. And if we go to the next slide, you'll see, so as Jim mentioned, there are different types of setups on the market, but what really shined for Jim and for others is that quality and reliability. And the reason we're able to deliver reliability that is far superior than anything else on the market is really because of what you see here on the screen. So I mentioned we're on our 8th generation of microinverters, and what we do to get to that 8th generation is that we're constantly working to improve the design from all the data I said that we collected in the field. And then before we go ahead and manufacture that generation, we do over 1 million hours of powered on testing. So what you see pictured here are pictures from our research and development lab, our R&D lab out in Petaluma, California. We also have another one out in New Zealand. And on the right, you can see those big containers. Those are actually environmental test chambers. So what that is it gives us the ability to put in dozens or up to close to 100 or so microinverters at a time. We can power them on with a DC source, and then we can close that chamber and create environments well beyond and way more extreme than the microinverters will experience in the real world. So we can, create the environment to be way hotter, way colder, way more humid, way drier, and we can cycle that and simulate a 25-year lifespan. And if you have looked into solar already with StraightUp or you've done any research on your own, you'll notice that solar systems are really benchmarked by a 25-year lifespan. And that's what we're really testing for and designing against. So especially here in the Midwest, we have some pretty cold winters, but some pretty nice and hot summers. So we can cycle those freeze-thaw cycles to really make sure that the microinverters are able to withstand environments well beyond what they're going to experience once they actually get onto your roof. And as a result, as Jim mentioned, we're able to provide a 25-year product warranty on all of the microinverters that we ship. So, Jim mentioned traditionally a string inverter would have, let's call it a 10 to 12-year warranty, depending on the make and model. Some as short as 5 years for larger ones, but ours is 25 years out of the box, and that's really a result of this incredible R&D and the incredible engineering team that we have here at Enphase, which has been able to provide that quality and that reliability. Another note to that is that we are NEMA 6 rated, or depending on where you are in the world, IP67, and what that is that's an ingress rating. So we're testing to make sure that nothing actually gets into your microinverter. It's up on the roof. You want to make sure no moisture gets in, no dust or anything else that's floating around in the air gets in. And to get NEMA 6 rated, it's a pretty high level rating. What you have to do to get that is you actually take your microinverter, or you take your product and you submerge it underwater for about 30 minutes, and you take it out and see if it works. And on the bottom left, you see we actually go above and beyond in that testing. So it looks like there's 4 of them. We wire up those micros and we submerge it into a pressurized vessel on the bottom left. And we actually power those on during the test. So there is a DC running through those microinverters, and they're powered on for the entire time. And we don't test it for 30 minutes. We actually test it for 3 weeks straight. So we're making sure that none of the liquid in there gets into the microinverter. And the way we're able to accomplish that is really with a potting material. So the microinverter, it's controlled by some pretty high power and cool computer chips that are inside the microinverter, along with some other electrical components. And then we actually fill the entire rest of the microinverter with a potting material. For lack of better terms, it's kind of like a rubberized material that just removes any air pockets. And it also helps control the temperature within the microinverter during those temperature fluctuations. And then when we're, so that's able to make sure that nothing gets in your microinverter. So no matter the snow, the rain, the dust storms, whatever you might encounter, which we don't encounter the most extremes, but whatever you would encounter, it's designed to protect against. And again, one step further, inside that liquid that we tested in, we put a dye in there, a UV dye, so that when we take them out, we can actually open up the micros and make sure that none of the dye has entered the microinverters, to really make sure that it's really tested pretty well. So again, we go above and beyond in our product testing, which has given us the highest quality, highest reliability of any inverter manufacturer on the market today, which is all boils down to our warranty. The other cool thing, which is pretty unique to Enphase, is something called burst mode. So in general, like Jim mentioned, when you're looking at solar, you've got your DC panels on the roof, but what matters to you as a homeowner is the amount of usable AC energy that it outputs. And so all inverters turn on in the morning when the sun starts creeping up, and that DC from the panel starts creeping through. So there's 2 cool aspects here. Traditional string inverters, because they're one large inverter for your whole array, they need a pretty high DC voltage to officially turn on and start cranking out energy for your home. Our microinverters, because they're small and 1 per panel, and they're converting less DC to AC for you, they can actually turn on a little earlier. They can turn on at a lower DC voltage. So you can start getting more production from your system earlier on in the day. But beyond that, we have something called burst mode. And what burst mode means is that even before the AC is officially turned on, even before you hit that official DC voltage, our microinverters have capacitors inside that can actually store up that bits of that DC, and when it hits the right amount, it can actually pass that out as usable AC, even before there's enough light to officially turn on your micro for the day. So you can imagine, as the lights really coming up in the morning, the sun's coming up, and you're starting to get some production on some panels, you can get more out of your micros in the evening when the sun is setting, and you can get every last bit of usable sunlight or if there's a pretty intense cloud cover or any other sort of partial shading that might impact the overall production of your panel, you're well protected with those micros, because they're going to make sure you're getting every last usable ounce of AC out of your system, which is, again, what you're looking for. You want every kilowatt hour your system can produce as possible. So those are just some cool facts I wanted to share with you guys about Enphase, and I'll turn it back over to you, Riley.
Great, thank you, Ashi. That was a very informative presentation. I just learned a lot. And I'd like to share with you all some more info about StraightUp Solar and how you can get started on your own solar project. First step to getting started on your solar project is you'll share some basic information about your home with a solar support specialist to start the process. And then you'll work with a project developer such as Jim, and you'll receive a customized system layout, proposal, and contract. If the layout and proposal looks good, you'll sign the contract, and then you'll be working with a project manager through the engineering, designing, and permitting process. And then you'll set a date for our highly trained installation crew to come out and build, inspect, and energize your system. And then finally, you'll have your very own solar array producing solar energy for you. I'd like to thank everyone for joining us today. Hope you learned something. Thank you, Ashi. Thank you, Jim, for joining me tonight.
Sure.
Really appreciate you guys taking some time and putting on this presentation.